Tēnā koutou katoa. Welcome to today's session. We're really fortunate to have you here, Brian. Levine, soil scientist, and he's here with us today to delve deeper into sediment mitigation options and really share his insights on how we can collectively address those sediment issues in our region. So yeah, welcome, and I'll just hand straight over to you, Brian.
Cool. Thanks so much. And it's really a pleasure to be here and get to share this information with you and everybody else. And I'm very grateful for the opportunity to provide this to the community. Something I'm very passionate about and something that I really hope is of service to the region.
Wonderful. Yeah, really appreciate being here. And I'm going to mute myself now.
Okay, cool. All right. So what I would like to discuss today and present is an approach to integrating sedimentation mitigation strategies in the Waitotra catchment. My email address is here. Any questions from the community that you'd like to ask, any further resources about the information that's shared, feel free to contact me. I'm more than happy to engage with anybody. A bit about myself, hopefully a reason to actually take what I have to say seriously, I guess. It's a bit of my academic background, bachelor's in environmental technologies, doing research in bioremediation. I've been environmentalist for my entire life and concerned, and was fortunate enough to follow that into my professional life. My master's research was on the long-term impacts of the Deepwater Horizon oil spill on the coast of Louisiana, where I did wetland biogeochemistry research, and that's really where I got into the science of soils and understanding chemical processes that occur in soils. And then from there, I ended up in New Zealand doing my PhD research at Massey University in Palmerston North, where I was quantifying the effects of detainment bunds. Detainment bunds at the time was quite a novel strategy to address contaminants getting into Lake Rotorua in surface runoff. And so that's quite pertinent. That background is quite pertinent to the conversation we'll have today, because detainment bunds, as we'll get into later in the presentation, are quite an effective way to address surface runoff and sediments delivering or runoff delivering sediments to streams and lakes and rivers. I ended up in Taranaki about 4 years ago. I was the land and soil scientist at TRC. And while I was in that position, I was a lot of my time was focused on developing the land and freshwater plan for sediments, working on the baseline and target setting documents, memos that have been published from the council. And yeah, anybody interested in sediments should look at those for references. I actually didn't share the links for those. I'll be sure to add that to the presentation after this. And yeah, I'm not just showing off my time at the Grand Canyon here in the picture on the right. This is actually relevant to the conversation we'll be having today. I was a technician at Grand Canyon National Park in Arizona. I was fortunate enough to do a 14-day river trip working on a fisheries project there. And I don't know if you can see there, notice that.
I'm sorry, Brian, I actually can't see your screen. You might have to press share again.
Interesting.
I saw it before. There we go. Yep.
We're back.
Sweet.
Okay. Yeah, so I'm not just showing off my good times of working in the Grand Canyon. Really, I want you to notice that water that raft is floating in looks a bit like Nesquik. Here we go. This is a picture of the Colorado River in Grand Canyon National Park. This is a protected area. It looks like there's an erosion issue there. This is the natural state of things in that river. It oftentimes runs quite clear because of a dam upstream of the river. They do sediment management, doing measured releases from the dam so that sediments are actually delivered downstream, because that's how the ecosystems evolved over millennia before humans were making an impact on the environment. And so my river trip was shortly after a rainy period, and during that rainy period, lots of sediments were naturally delivered to the river. So this is something to keep in mind throughout this presentation, and moving forward in the catchment is thinking about what is actually achievable. What is the catchment trying to achieve? No sediments being delivered to rivers. It's not realistic, nor is it the quote unquote natural state of things. Um, so yeah, we'll get into the importance of recognizing that throughout this presentation. So I've organized this approach from kind of two scales, one at the catchment scale, and that the catchment approach towards implementing sediment mitigation strategies. And then part two, because different scales, different ways to approach these things, adopting mitigation strategy at the farm scale. So how to move from the picture on the left, which is the need to uh, adopt mitigation strategies, to the picture on the right, dirty water to clear water. And in doing so, figuring out how to work smarter and not harder. Um, Understanding what's actually achievable is going to be a very important part of this process. And once there's an understanding on what is actually achievable, figuring out the best way to get there. So the outline of approaching part one. TRC is going to be a major resource in this process. They have a great tool called the SedNet NZ model. So this is a regional resource, reaching out to the council and asking them for the results for the model for the Waitoto catchment specifically is available. The information that's relevant to addressing erosion and sediments in the Waitoto catchment and figuring out what can be achieved involves recognizing what the non-native cover is, as well as identifying the highest yielding watersheds with the most non-native cover. I'm going to get into each of these points in the following slides, go into more detail. This is just an outline slide. So once you have the information and are working with that with the SedNet model, then you can work within the catchment group, do some groundwork, ground truth that model, identify existing and absent management practices, and then figure out a water clarity monitoring project and approach. All of this needs to be done to develop an understanding of what is actually achievable in the catchment. So I know TRC was brought on board to talk about sediments. I hope they talked a bit about the SedNet model. I'm getting a nod from Lisa there, so that's good. I'm not going to get into too many details about it. The most important thing that I'll highlight is that the model gives data about, it incorporates information about future soil conservation scenarios. This is the fully implemented and matured whole farm plans and riparian fencing that TRC plans to get done. And it works with that under different climate change scenarios. Once again, this information will allow the decision makers and the stakeholders in the catchment to understand what are the appropriate goals to set and where the opportunities to address erosion are. Okay, so it's important to identify that non-native, the watersheds within the catchment that have a non-native cover, because that's the places where sedimentation erosion can actually be addressed. In a nearby catchment in the region, in the name's just now slipping my mind. There's a catchment in South Taranaki to where the non-native cover is contributing so many sediments that it's not going to be able to achieve anything above the D band in the MPSFM. I don't know if the TRC presentation discussed the achieving these targets. Essentially, what those results are saying is that there's enough natural erosion that occurs on native cover land that it's going to be very difficult to improve, quote unquote, improve the water clarity to levels that the government, when they came up with their models, deemed accessible. So achieving those goals that the government set is not a realistic goal to achieve, and that's why understanding where the sediments are coming from, whether these are the watersheds with the greatest sediment yields meaning tons per hectare per year, with the greatest proportion of non-native cover. So this information comes from that sediment model, and this is going to allow people in Waitotoa to identify the critical source areas at the watershed scale. A couple of other things I have to say about the model. All models are wrong, some are useful. That's a quote taken from a famous statistician. The specific numbers in the model saying these are the yields, those may not, very likely won't reflect the actual yields in reality in the real world. However, the results from the model are likely to be directionally correct, and they're quite useful for spatial and temporal comparison. So meaning these are the hotspots in the catchment. These are the hotspot watersheds that particular attention should be paid. And over time, between now and future climate change projections, here's the likely directional change over time. And those are important to keep in mind. This slide's about the non-native cover. Already mentioned, mitigation can only occur on the non-native cover. Yeah, that table is not very important, but it does show what was considered natural cover and non-natural cover in the model. And once again, I use the picture from the Grand Canyon to show a lot of sediments can come from native cover. Okay, so outline slide for the catchment group groundwork. This involves ground truthing the model and the hotspots that have been identified at the watershed scale. The importance of noting areas with visible erosion and where enhanced erosion controls exist. The need for land managers to have TRC farm plans in place. I go into specifics there, and then how to develop a monitoring plan. So ground truthing is important because we are working with a very large area, and I'm assuming, just like everybody else, there's a limited amount of resources to work with. Therefore, it's to work efficiently, you need to focus on those hotspot areas. In order to do that, you work with a model that's going to give you an educated guess on where these hotspots are, where to apply the most attention and limited resources. Then you go out and confirm those. So the next slide will talk about the important areas, but you want to be able to confirm those areas concerned. Where's their visual erosion taking place? Making note of that, and identifying opportunities to address the erosion, ensuring that where the model says there's non-native cover, there is non-native cover, as well as the existence of erosion and whether there are erosion management practices in place or not. So within the watersheds, there are CSAs, critical source areas. This is where there is a hydrological factor for erosion that's runoff, surface runoff, that is creating a force that is causing the erosion and transporting the sediment to the streams. So where erosion takes place, where there is runoff, and where that's hydrologically connected to the stream. That is what's considered a critical source area. Research has shown that headwater subcatchments are responsible for the majority of stream flow and hydrochemical responses, which would include sedimentation processes that deliver contamination, such as sediments, to the stream networks. So that gives an idea of where these hotspots that the catchment group is going to want to work within, these headwater subcatchments. Where can you get the biggest bang for your buck with the limited resources that you have? So known critical source areas in the catchment include the steep hill country, as well as where the erodible soils are, the sandstone, the mudstone, the pawpaw. So then the associated erosion risk factors that those areas are responsible for. So besides just the hill country and the erodible soils are the riverbanks and channel beds. This is where slumping can take place, where the force of the river, particularly during storm events, can cause a lot of erosion. The non-native species along the river channels, when those die and fall over, when those are not managed correctly, those can cause river blockages and cause a lot of bank instability, which leads to a lot of erosion of the river bank and deliver a lot of sediments downstream. And then there's the overland flow paths and small streams. This is where that storm-induced surface runoff delivers those sediments and debris. And this is potentially caused by poor maintenance. So ground truthing is also going to involve establishing a monitoring plan within the catchment. This enables the stakeholders to identify what was the state before and after adopting certain mitigation strategies. We'll talk about the actual ability to measure the efficacy of the strategies. That's an important thing to take note. However, oftentimes there's discussions about how much background data is necessary in order to make the decisions to implement strategies. If you know there's a problem, how much background data do you actually need? Sometimes too many resources get put into place for these monitoring projects when there's obvious issues, when you can look at the hillside and say, wow, there's a huge scar on that hill. A lot of sediments are getting into the stream from there. How important is it to I guess, confirm that that's a source of sedimentation in the stream? So, yeah, if there's an obvious problem, go ahead and start addressing that issue is what I would say. So, kind of outline steps for developing that monitoring plan would be to identify the sediment hotspots, work your way upstream in order to identify those critical source areas. So, the the visual clarity downstream of a critical source area should be worse than the visual clarity upstream from that critical source area. And so when you notice that difference in visual clarity, okay, that's going to be a source of sediments in the stream. How are we going to address this area? And then that allows you to track the clarity trends where management actually takes place. This is where you can start to notice the impacts of the efforts. This is so the tools. This is a visual clarity tube. That's what that picture is. This is how community members can do their citizen science to do their measurements, and in doing so, collect georeference data, so the locations, and take photo documentation. This link here Let's see if I can, yeah, cool. This link here is from NIWA. This walks you through how to do SCHMAC water quality testing and the visual clarity procedure for that. There's a nice video here. So yeah, be sure to check this out if and when you start doing your own citizen science there, if you haven't already started. I believe I'm back to the presentation. Good. And then figuring out how often you want to do your frequent your monitoring, whether it's going to be on a monthly or just an event basis. That will depend on the resources available, the enthusiasm of the community to do the testing, figuring out, because erosion and sediments getting into the streams is such a storm-driven event, potentially the best type of data you can collect is during the storm events, because that's when the sediments are going to be delivered to your streams. Okay, so hopefully that helps give a pretty high altitude view on how to develop a plan to get mitigation strategies in place at the wide catchment scale. We're now on to part 2, which talks about adapting or adopting the strategies at the farm scale and the decisions that take place to get that done. So, outline slide here. It's important to understand the factors that affect sedimentation, so that affects the sediments getting into the streams. The types of mitigation strategies, we'll start with the high level view and then work down into more specific types of mitigation strategies. Specific mitigation options for the Waitoto catchment, working with the characteristics of the catchment and understanding what most effective strategies are available for the landowners and stakeholders in the catchment. An understanding of the factors that influence the strategy effectiveness, just to get an understanding of what makes these strategies work and what's going to challenge them. Really things to consider for decision makers and stakeholders regarding the implementation of the strategies. Steps towards adopting the strategies, just to give you an idea of what it will take to come up with the plan and to make the right decisions. And then challenges for measuring the effects of mitigation strategies. It's an interesting subject, at least for me, just how difficult it is to quote unquote prove a strategy is working, and weighing how important is it to be able to actually get that in numbers, knowing that these strategies actually do work. It just may be difficult to prove it. All right, so factors affecting sedimentation. This can be broken into loading factors. These are typically management decisions. You see the list here. These, broken into pastoral agriculture found in the Waitoto, as well as forestry management decisions. Forestry is a part of the catchment. Spatial factors. These are more physical in nature: soil types, water pathways, slope and topography. The distance to the stream affects what type of sediments are delivered to the stream, and the land uses, which affects the land management. Then the temporal factors, things like precipitation, the changing water pathways, ephemeral stream paths. So those are the temporary streams that occur on the land during storm events versus perennial streams. And then the attenuation processes that are related to the mitigation strategies and the land management decisions. All of these are going to impact the potential for sedimentation to occur in streams. So because land cover affects erosion, the mitigation options that are available depend on the land use. And so the land uses, this is kind of broken, the slide is broken into the different types of land uses in the Waitoto catchment. In the lower catchment, it's mostly pasture-based agriculture with some cropping and exotic forestry. Mid-catchment, still pasture, some cropping, more forestry, and then some more natural land cover. And then in the upper catchment, largely forested, with a lot more native cover. So now we know the land uses, moving now into the types of mitigation strategies that are available in the pasture setting. We'll talk about the forestry setting after this. But in a pasture setting, there's three overarching types of mitigation strategies. These include the infield, the edge of field, and the off-field strategies. Typically, infield strategies are the most cost-efficient ways to address erosion, while off-field strategies are the most expensive and less effective. So infield strategies, this is what's going on in the productive paddocks. And so mitigation options in the paddocks to decrease the amount of erosion that's occurring. These include the adoption of different regenerative agricultural techniques. This improves the soil stability as well as the ability for water to infiltrate the soil. The less water moving over the land is going to decrease the amount of force that's able to disturb the soil and transport it downstream. There's different grazing management options to manage the erosion on the land, the use of cover crops, critical source area management, limiting livestock access and using rotational grazing, taking in mind wet seasons and particular areas that are prone to things like pugging. And then fence line placement, understanding how decisions on where you're putting your fences is going to affect the types of erosion and the amount of erosion that's taking place. And that depends on different land contours and putting your fencing across a slope. So on the right side, these are the factors that I listed earlier that affect the sedimentation that's delivered to streams. And I put in bold all of the things that are addressed with this list. Pretty much ticks all of them except precipitation, which essentially no control over. Beyond that, and this is where the synergy with the regional council comes into place. The council offers a program through the land management office that is no cost and has no obligation. I know that the TRC had a representative give a presentation for this group also, and hopefully they went into the details of this, so I won't talk about all of these, just highlighting again that a lot of erosion mitigation strategies are offered through developing a comprehensive farm plan with the council, and that's no cost. So that's a great resource. I hope everybody there gets their farm plans done because that's going to go a long way in the catchment. Yeah, just here's the links, here's the contact information, link to information sheets that are available so people can educate themselves about what the council has to offer. Okay, moving on to edge of field mitigation strategies. This is a growing field of interest in the scientific community regarding the reducing the impact of agriculture on the environment, particularly water quality. And these are strategies that are above and beyond what the land management office has to do. At least it includes things beyond that. The land management is involved with riparian buffer plantings, which is awesome and very effective. Really, what's beyond that is the construction of wetlands, sediment traps, and detainment bunds. Yeah, these are larger scale strategies. These are going to take um, development in certain areas of the farm. This is going to take an increased amount of investment. There's going to be maintenance involved, and it's going to be variable in effectiveness and longevity, depending on the amount of sediments and water being delivered to these strategies. So, yeah, wetlands do have sediment uh, sedimentation benefits. However, if wetlands receive too many sediments, it could cause issues in the performance of the wetlands, both in terms of its ability to treat water in general, um, and just the general health of that constructed wetland and the benefits it could offer. Detainment bunds, on the other hand, um, and I previously mentioned, are a highly effective way to manage sediments in certain catchments. I consider myself somewhat of an expert in this field. This is what I spent 4 years researching in the Lake Rotorua catchment. So I'd like to talk about this because it is a novel strategy in New Zealand. It's being rolled out across the country, and there could be opportunities in the Taranaki region to adopt this strategy, which is quite cost effective, and it could be a great option for land managers. So, a detainment bund is a constructed um, dam, essentially small, low dam up to 3 meters in height from the original ground, that blocks ephemeral stream paths. So that's the overland flow that develops during storm periods. So on the right side of the slide, there's an ephemeral stream path. That's the inflow. That flow is stopped by the detainment bund. So a pond forms in that area. In order to protect the structural integrity of the bund, there's an overflow pipe that decants the water and can deliver the overflow downstream. So there's a pipe that goes through the bund. And then the technique that's advocated for is to hold that water in that pond for 3 days so that it doesn't affect the productivity of that pasture. And during that time, water's infiltrating the soil, which removes some of the nutrients, nitrogen and phosphorus, as well as allowing the sediments to settle out of the water column, preventing them from being delivered downstream. My research found that over the course of a year, about 40 to 60+% of the sediments from the treatment catchment were removed from or prevented from traveling downstream. And that's a really great result. The results will vary depending on things like the climate and the amount of erosion that's taking place, as well as the size of the catchment that was treated. So this is all it looks like when it's in the field. The last slide mentioned some of the things that were in place to do the measurements of the research that I was doing, but this is that upstand riser. This is the hill. And fortunately, Paul Turner from Taranaki Catchment Communities has been trained on how to locate appropriate locations for where to install detainment bunds. There's been a huge advancement in utilizing technology, GIS programs to locate these. Back in the day when I was involved with detainment bunds, it was more of a hands-on working with topography maps practice. I almost call it as much art as science in the process. Now it's quite a scientific and streamlined process that Paul is empowered to do, which is great. That's going to be a huge community resource for getting these out there and controlling the amount of sediments that are delivered downstream. So this is a picture that I took during my PhD. This is that ephemeral stream path. Out in the background, you see a pond forming. That's where the bund is. This is looking back upstream. This is a bunch of scientific equipment that I had in place to do my measurements. Really, all that needs to be there is that upstand pipe that was pictured in that kind of boring looking picture. That's all it is. You build and you figure out where you can pond water, and you block the overland flow, and you let this pond sit there for 3 days before releasing that water downstream. As I said, it's quite novel. It's being rolled out in different regions. More and more research is taking place for how it performs under certain situations. It's been found to be highly effective at reducing the amount of sediment being transported under the places where it has been researched. It's relatively cheap to install, particularly if there's not consents that are necessary from the council. That's something that needs to be developed here in Taranaki. Um, figure out if there are consents necessary and potentially workarounds for that. Fortunately, there are local experts in this field for getting these potential locations identified. That's Paul. And then, yeah, just further advice from somebody like me who has a pretty extensive experience working with these bunds. And here's a great link to learn more about detainment bunds. Okay, so further options to consider. This is just a nice little interactive screen website that's available to learn more about the various options, a brief description of them, the co-benefits involved with getting these in the field beyond uh, erosion control and sedimentation, the factors that limit their uptake, and the different measurements involved with getting them installed. This is the website. Uh, I'm running a little long in the tooth here, so I don't think we need to go look at that. We'll take a second to do that. Here we go. Yeah, so this is that website from Our Land and Water, which is a great resource regarding water quality control. These are the various contaminants that come from different forms of agriculture. We're talking about sediment, so we'll click on sediment. We want to learn about the mitigation options for a dry stock farm. Click on that. Here's the different options that this website offers to learn about. We'll talk about constructed wetlands because I didn't go too much into it. Here's the description and all those little things that I talked about to learn about. And then below that, there's different resources that go into more specifics. So yeah, this kind of brings in together a lot of information, gives a high level view of the various mitigation options available. Great resource to do a quick little research venture. All right. Beyond that, if you want to get a bit more into the nitty gritty of the various mitigation options available, including how effective they might be, a range of that, and the relative cost of doing these things. This is a pretty long research paper, but I point you to table 4 of the document, which show here. We'll go to a quick tab here to show this is what this offers. So constructed wetlands, this is available for all different types of farming, opposed to a dairy farm or deer farm. I'm sure there's beef and lamb further down. So constructed wetland, a longer description than that previous website I showed. Its effectiveness for the various contaminants. In this case, it's high for suspended sediments, so sedimentation. Its relative cost in terms of the amount of sediments you can remove from the water for the cost of installing the constructed wetland, it's considered medium. The reasons for the variability in its performance is there. Factors limiting uptake. It's not always suitable on certain types of land. Also, it's not cheap to install wetland most of the time. The co-benefits, biodiversity is a huge one, as well as the wildlife habitat that it creates, and then the research papers that talk about them. So that's a great resource also to learn more about mitigation options available. Okay, so we've talked about in-field strategies. A lot of that's land management. A lot of that can be covered in the farm plans that the council has to offer. We talked about the edge of field strategies, constructed wetlands, detainment bunds, plantings, a bit more expensive. Now we're talking about off-field mitigation strategies. I believe there's another council representative, probably Chris Vickers, who's talking about river management. Those types of things will likely have an impact on the erosion of the stream channels. A lot of these strategies touch on that. Also, there at the bottom, there's the afforestation on the sandy soils, which are highly erodible and present in the sand country in the Waitara catchment. So back to critical source areas, specifically in the Waitara catchment, and an idea of the mitigation options available to deal with each type of critical source area. So we'll go through each of these pretty high level. So you have your steep hill country, pastoral agriculture with your erodible soils. These are the erosion risk factors. Thinking about what options are available there to deal with that. These are the farm plans. These are the in-field strategies. This is identifying the appropriate land use, going through the land use capability work that the council does with the farm plans and getting those strategies in place. The riverbanks and channel beds, that's going to be your riparian planting, and the river management that the council's been talking about. Moving on, invasive infestations in the channels. This is the stream bank management. This is going to be clearing the channels, making sure there's not a blockage in the system that's going to lead to erosion of the riverbanks. And then there's the addressing of the overland flow paths, figuring out how to disrupt that flow so that it reduces the amount of force that the water has that's causing the erosion and transporting sediments. So this is planting grass, swales, planting trees to just block the flow of water, installing those detainment bunds, as well as considering installing wetlands. Exotic forestry is a source of erosion. It is a prominent land use in the Waitara catchment, so it is going to be a source of sediments. Yeah, the harvest and the infrastructure is going to be a source of this, of the erosion. Pine trees, they have a shallow root system comparable to more native species. This leads to potential erosion. The potential for wilding spread, pine trees getting into places where they can't be harvested, where they'll eventually fall over. That root system gets upturned and leads to a lot of erosion, hillside instability, and just the general unharvested trees. This is talking about the potential for carbon forestry, and the importance of planting, being able to harvest the planted pine trees. So, mitigation options to address these various forms of erosion that come from exotic forestry. Considering more deep-rooted exotic species, these are your redwoods or Douglas firs in the more high-risk areas, as well as allowing native plants to grow in the riparian zones and gullies. Because the harvest is often clear cut, that exposes the soil to rain, which is going to start the erosion process. So adopting selective logging, avoiding clear felling forests, trying to maintain a ground cover and that root integrity, ensuring that the infrastructure and planting doesn't go into the buffer zones around the riparian areas. It's going to reduce the amount of sediments going into the streams, as well as providing the integrity for those stream banks to not undergo slumping. And just general erosion control infrastructure around the roads, avoiding unnecessary soil disturbance. The post-harvest management, seeding the harvested areas with fast-growing grasses and things like manuka, and natural regeneration, allowing that to recur to just get that ground cover, to get roots in that soil to hold it in place. And having a wilding management program in place, particularly in the conservation areas, so inappropriate trees are not popping up in inappropriate areas. Yeah, moving towards the end of the presentation here, these are the factors that are going to affect the various mitigation strategies. These are physical factors, the land use and vegetation factors, socioeconomics, and the decisions that those will have on, what strategies are adopted, how extensive those strategies will be, and that's those effects of how effective the strategies will be there, and then the climate factor. So, yeah, the physical factors, this is the topography and slope, the erodibility of soils, the changing stream morphology, whether streams are changing paths or not, um, as well as the ability to access the erosion-prone areas to put mitigation strategies. All of these things are going to affect the effectiveness of the erosion and sediment controls that you put in place. The speed at which the water moves, the amount of water that's moving, the load of sediment that's being delivered to the management strategy, whether it's a riparian buffer, a detainment bund, all of these things are going to affect how these strategies perform. And because land use and the vegetation cover, the land cover affects the physical factors, this is going to affect how the strategies perform. Socioeconomic factors, we're talking about the limited resources available at such a large scale. When deciding what to do, what management changes that are being considered, and or land use changes, there's positives, there's costs and benefits, both sides. So installing something, the construction of a bund or a wetland, there's going to be a cost to that. There's time and money that go into that. There's the land that comes out of productivity when you do riparian planting. Instead of allowing grazing to occur right up to the stream bank, you're taking land out of quote unquote productivity. The time involved with doing the installation, the work that goes into that, the sacrifice of that, the potential time for maintenance, these are all costs. Then there's the benefits, the lower amount of erosion. Soil is a valuable resource. This is what leads to the productive nature of the land. So keeping that in place is going to be a huge benefit for productivity. The improved water quality, that's why we're talking here. And then the potential for co-benefits, the removal of other contaminants such as nitrogen or phosphorus, as well as creating habitat for greater biodiversity for things like riparian plantings and wetlands. Consider the maintenance and the longevity. These are going to, whether a strategy decreases in performance over time, how often the maintenance can take place in order to get the strategy potentially running optimally. And lastly, the climate factor that's going to impact the strategy efficacy. Climate change is expected to increase the rainfall intensity, which will lead to greater erosion taking place. So something to consider at the catchment scale is that the increase in climate-driven erosion that takes place in the natural areas where mitigation strategies can't be adopted could potentially offset the gains from mitigating sediments coming from forestry and pastoral agriculture. So although great things can take place on these non-native cover areas at the catchment scale, there's a potential for that to be offset, and that's where the thinking about using that SedNet model to understand what's actually achievable in the future is really important. All right, so back to kind of a high level strategies to or steps towards the adoption. Work with TRC. It's a great resource. The land management team's awesome. They provide some really incredible services for farmers and land managers. That SedNet model is going to give you a great background information to work with to figure out where to do your ground truthing and potentially start your activities in terms of noting what's on the land as well as monitoring what's going on in the streams. Then you start to do that ground truthing and figure out where management is present and absent, looking for those opportunities. And then lastly, beyond working with TRC to get the farm plans in place, there's Taranaki catchment communities to further discuss the mitigation options, the potential for something like a constructed wetland, something like a detainment bund, working with them, figuring out where these potential strategies could be placed and how to get them in place. And that could potentially be done strictly through TCC. I'm not exactly sure. I know they've been working with other consultants that come in, do an in-depth assessment, and get land managers the resources they need to get these strategies in place. Okay, last point, high level, it's really data science has shown just how difficult it is to measure the impacts of the adoption of these strategies. Monthly monitoring, it just doesn't add enough numbers to show potentially significant differences. There's a link to quite a technical report that talks about this. The thing about it is that increased monitoring comes with a pretty high cost. And at the scale of the Waitotora catchment, with what I imagine to be fairly limited resources in order to do all of the work that needs to be done to improve the situation, monitoring doesn't need to be, from my professional opinion, that high on the priority list. It's useful. It's in a way, it's fun to show, oh, we did achieve something here. Those changes did achieve something. However, getting the data to actually show you did something, it may not come out in the data. This report really drives that point home, and I want people in the community to understand, even though you're doing the right thing, even though the best management practices are being put in place, even though the amount of erosion is decreasing potentially significantly over time, it just may be difficult to prove with the numbers. Don't let perfection get in the way of good enough. Get the best management practices in place. Do the good farm plans. Get those in place. Do the right thing. It's worth it. Climate variability is also going to, make it more difficult to show those the impacts of those changes. All right. I like to finish with this slide. I used to have a non-AI generated image of a Fraser printed elephant balancing on a beach ball that I love to show. AI is pretty amazing for generating these types of images. This is a balancing act. Money's involved, time's involved, limited resources are involved. Productivity, keeping the land productive, people's livelihoods are on the line here. These are really important factors, but we also need to balance this with the values of the community, which is water quality and protecting the beautiful resources that New Zealand has, which is high water quality and the cultural importance of all that. So it's a really difficult thing to approach. It's not easy. It's a balancing act. yeah, there's going to be sacrifices, there's going to be compromises. Um, yeah, I hope this presentation helps everybody make better informed decisions, um, has a better resource base to tap into to learn more about the topic, and will lead to everybody working stronger, smarter, and hopefully not too much harder in the future because everybody's working hard these days. With that, I hope to field any questions wherever they come from at some point. And yeah, thank you very much
Mm.
for letting me speak to you.
Ngā mihi kia koe, Brian. Thank you so much for your insights, sort of painting the big picture, but also really delving in sort of the details. Yeah, sounds like, there's a lot of work to do, but many options you talked about, from sort of big to small, and lots of good resources that people can tap into to address the sediment issues that we have in the region. To be honest, a lot of the questions I had you already answered, but really, and I'm also, hoping through the other presentations, of course, the picture will get even bigger and more comprehensive, in terms of talking about state of affairs, where are we actually at from TRC side, but then also talking about best practice examples sort of in the region, to really see in terms of, what can we do as a community and as a different, entity in that community to all address those issues together. So maybe rather than kind of, I think there's a lot of information already in there. I'd like to just encourage everyone to really reach out to Brian, or to us, Wildfire Taranaki, if you'd like to be in touch and, kind of continue that conversation, but equally also to Paul from TCC, Taranaki Catchment Communities, and obviously the team at Taranaki Regional Council. So yeah, lots of good options out there. Is there anything else you want to add, Brian, before we wrap up?
No, that really covered it, and yeah, I really hope to engage with the community there and anywhere else that are facing water quality issues and sediment issues, in particularly.
Wonderful. No, thank you so much for today, and again for all the resources you put out there as well. I'm sure that can be a good, either starting point or for people to kind of progress their journey even further. So I'll just kind of wrap up the recording here. Ka kite.